All right, welcome to The Explainer. Today, we're going to dive into one of the most exciting areas in AI right now. How do we teach a model that knows pretty much everything how to actually think? It's the difference between just having facts and being able to solve problems. And we're going to break down exactly how it's done.
It is a massive challenge. See, once an AI has been trained on just, incredible amounts of text, it has a ton of knowledge. But here's the thing, right? Knowing stuff is one thing. Applying it logically to solve a problem you've never seen before, that's the real game. It's like the difference between just memorizing a textbook and actually being able to solve the problems at the end of the chapter.
So you've got two basic paths to make an AI better at this whole thinking thing. On the left, you can just throw a ton of computing power at it every single time you ask it a question. But the approach on the right, well, that's where things get really interesting. You invest that computing power up front, during the training, to make the model itself fundamentally smarter. And that's what we're going to focus on today, using a really powerful technique called reinforcement learning.
All right, so let's get into it. We're going to start with the classic method, the one that first made AI chatbots feel smart to millions of us. So the key concept here is something called reinforcement learning. See, instead of just training a model to guess the next word in a sentence, we totally flip the script. We're training it to make the entire answer as good as possible. It's kind of like training a puppy, right? It does something good, you give it a treat. That reinforces the behavior. For an AI, that treat is just a reward score.
And the first big breakthrough using this was RLHF. You've probably heard of it. Reinforcement learning with human feedback. This was the secret sauce that turned these powerful but sometimes kind of clunky models into the helpful assistants we know today. It was an absolute game changer because it taught these models to give answers that we humans actually find helpful.
Okay, so how does this thing actually work? Well, it's a two-step process. First, you get a bunch of people to sit down and rank different AI answers to the same question. This one's better than that one. You take all that data, all those human preferences, and use it to train a whole separate AI to be a judge. Then, for step two, that AI judge becomes a coach for the main model we want to improve. The main model creates an answer, the judge scores it, and that score becomes the reward that helps the model learn. And this diagram, it lays out that whole flow perfectly. Up top, you see the humans ranking answers to train that purple judge model. And then, down below, you've got our main LLM, the orange one, getting coached. It spits out an answer, the judge scores it, and that feedback loop just keeps making the LLM better and better. But, as powerful as RLHF is, it's not perfect. That whole human-like judge thing, it's got some serious limits. And that's what led to the next big evolution here. Yeah, here's the bottom line. Building and training that separate AI judge is a huge, huge deal. We're talking about another massive language model that's super expensive and complicated to train all by itself. It's basically like having to hire and train a whole separate tutor just to teach your student. So that begs the question, right? What if we could ditch that expensive, kind of subjective tutor for something simple, something objective? And that is the big idea behind reinforcement learning with verifiable rewards, or RLVR. So instead of asking a judge, which answer feels better, we ask a simple verifier. Hey, is this answer factually correct? Yes or no? It's like swapping out a film critic for a calculator checking a math problem. One is subjective, the other is just right or wrong. And when you put them side by side, the difference is just night and day. RLHF, that's like art class. It's subjective, it's nuanced, and honestly, it can be kind of inconsistent. RLVR, though, that's math class. It's like a true or false quiz. The answer is either right or it's wrong, period. That makes it objective, way simpler, and, this is key, super scalable. Okay, now check this out, because what's so cool here is just how much simpler this new process is. I mean, just look at that loop. The LLM gives an answer, a verifier checks it, is it correct? And that simple yep or nope is the reward that immediately updates the model. There's no separate judge to train, none of that. It's just direct, it's fast, and it's all automatic. Okay, so we've got the why. Now let's get into the how, because this simpler idea is the foundation for a really powerful training recipe that is totally shaping the next generation of AI. So think of it like this. RLVR is the overall philosophy, right? The big idea is use verifiable rewards. But the actual step-by-step recipe you follow in the kitchen, that's an algorithm called GRPO. RLVR is the destination. GRPO is the GPS telling you how to get there. All right, let's break this down because I know the technical stuff can get a little heavy, but don't worry, we've got an awesome analogy to make it all click.
Just imagine our AI is a chef, and they are on a mission to perfect their lasagna recipe. So, it all starts when a customer orders lasagna. That's our prompt. Now, the chef doesn't just make one dish. Nope. They try out a few different variations of the recipe at the same time. In the AI world, we call these rollouts. Then they serve all the different lasagnas, and the customer gives super simple feedback. Thumbs up for a good one, thumbs down for a bad one. That's our reward signal. Okay, now for the fun part, the learning. The chef looks at all the thumbs ups and thumbs downs and figures out which of their recipes were actually better than their own average. This little bit of insight is called the advantage. They also take a second to think, okay, how weird was that recipe for me? Was it my usual style or did I go way off script? And then they put it all together to tweak their core cooking style. They're going to do more of what led to a thumbs up and less of what led to a thumbs down.
And what we just described with the chef, this is what it looks like as a formula. I know it looks complicated, but it's the exact same logic we just talked about. The different attempts, the rollouts, get their rewards. You use those to figure out the advantage, how much better or worse each attempt was than the average, and that signal is exactly what's used to update the model. It's a beautiful system for automatic, data-driven improvement.
So the big question is, why is this method, this modern, automated recipe, becoming the gold standard for teaching AI how to reason?
Well, the advantages are pretty hard to argue with. First off, you completely eliminate that expensive, separate judge model. Gone. The rewards, the feedback, it's consistent and reliable. It's not all noisy and subjective like human opinions can sometimes be. It scales like a dream because you can automatically check millions of examples without needing more people. And maybe most importantly, it allows the model to get creative and explore different ways of solving a problem. It doesn't care how it gets there as long as the final answer is correct. And all of this leaves us with a really fascinating thought to end on. When an AI can automatically check its own work and improve its own reasoning, what new kinds of massive problems are we going to start trusting it to solve? We're talking about science, engineering, medicine. The possibilities just explode. It really is a powerful new recipe for building intelligence.